Okay, so once again, good afternoon. So today we'll start with the experiment number 3. So the experiment number 3 is based on the your chapter number 2. So what was the chapter number 2 we have discussed related to the method study. In that particular method study, we have discussed the different types of the recording techniques. So different types of the recording techniques in the sense we have discussed the different types of the charts, then different types of diagrams, then different types of the motion studies, different types of the layouts. That recording techniques, basically three recording techniques we have discussed in that particular chapter number 2. In that, the first discussion we have started with the different types of the charts. So whatever the activities we are performing in our day-to-day applications, I am taking the example of the day-to-day application. So afterwards, we will go for the industry. So what are the activities we are performing in our day-to-day applications? All the activities can be represented in the symbolic manner. But what happens in the industry? The operators, some operators are the skilled operators, some are the unskilled operators are there. Okay. So those who are the skilled operators, they can understood all the things very well, no problem. Sometimes they can understand the things in the descriptive manner, but some unskilled operators are there that they are unable to read it. Sometimes whatever the informations are given in Marathi language, sometimes the information is given in the English, but that unskilled operator is unaware what information is represented in front of that. So in order to avoid that particular situations, so whatever the activities we have to perform or whatever the activities that operator has to perform, that all the activities can be represented in the symbolic manner. So for that purpose, the standard symbols are used in the industry, and through that particular symbols, we can represent all the activities in the symbolic manner. For example, we are performing the number of operations on the lathe machine, drilling machine, CNC machine, VMC machine, whatever the machines are available. So if I am performing that particular operation, maybe drilling, maybe milling, like that. That operation can be represented in by the symbolic manner. So for that particular operation, separate symbol is there. If I have stopped my operation, I am in the idle condition. That means there is a delay in my operation. That delay can be represented by the another symbol. If I am transferring that raw material from one location to the another location, that means transportation is taking place. Again, that transportation can be represented by the symbolic manner. Okay, if I have to store my component at the store department, so that storage can be represented by the different manner. Sometimes we are performing the number of operations simultaneously. Maybe drilling operation simultaneously performed, maybe another boring operation can be simultaneously performed. If simultaneous operations we are performing on any type of machine, it can be represented again the another symbolic manner. So through this particular symbol, that unskilled operator will get the information immediately, instead of giving the information in the descriptive manner. So same information I will represent in the symbolic manner, because through that particular symbol, the skilled operator as well as unskilled operator can get the information immediately. So for that purpose, this method study chapter or this concept plays very important role. Okay, so here in the chapter number 2 also we have discussed. So here once again we are going to discuss the different types of the symbols. So here I have represented symbol, title, description. So here the first column represents the types of symbol. Second, it represents the operation, and the detailed description is represented by the third column. So here the first symbol is represented by O, or it is represented by the circle. So what that particular symbol represents, capital O or the circle, it represents the operation. So what are the number of operations we are performing? Maybe you are clamping the job, you are removing the job, you are starting the machine, you are performing the job, you are doing the operation. So whatever the activities performed by the man or operator on that particular machine, that operation is represented by this circle or capital O. Then second symbol is represented by the arrow. So arrow represents transport. So if your material, your component, your raw material, your finished goods is moving from one machine to second to third, so that transportation is represented by this particular second symbol, which is represented by the arrow. Then third symbol is represented as a delay, capital D. You can see the third symbol, capital D. It is called as a delay. So whenever we are working on any machine, immediately tool breaking is taking place. Immediately some accident is happening. The coolant is finished, oil is finished. At that time, we have to stop the machine. we have to replace the tool, we have to change the coolant, we have to change the oil. That means we have stopped your operation, means the delay is obtained or delay is formed in your operation. That delay can be represented by the capital D. So name is given delay. Then fourth symbol, it is inverted triangle. It is called as a storage. So once your total raw material is converted into the finished goods, that finished goods we have to store in the store department. So that storage of the component, it is represented by this inverted triangle. And last symbol is called as a rectangle, or it is called as a square. It is called as a inspection. So if I have performed one operation, for example, I have performed the turning operation, then I have to check the diameter. That means after performing each and every task, I have to go for the inspection. Means I have to check the dimensions, whether that component is manufactured as per the dimensions or not. Therefore, you can observe whenever we are working on the lathe machine, one raw material in the form of circular rod is given to you, and initially we are performing the turning operation. That means we are reducing the diameter. Once first cut I have taken, second cut I have taken, again I will take the vernier caliper, I will check the diameter. Okay, then if your diameter is again more, again I am performing one more turning operation, again I am checking the diameter. So after performing 2-3 operations, if I am checking the dimensions of that particular body, that concept is called as a inspection. So that inspection can be represented by the square or the rectangle. So that inspection can be taking place whenever we are operating on the machine. If your product is totally finished, after finished product, that product can be entered into the inspection department. At inspection department also, again, all the dimensions are to be measured. So whenever we are measuring the dimensions, we are checking the dimensions, all that particular activities we are performed under the inspection. And these are the 5 symbols which are used to represent the task performed by the operator. And through this particular symbol, that unskilled operator will get the information that now I have to perform the operation. Now I have to go for the transportation. I have to take the delay. Now here I have to go for the storage department. Here I have to go for the inspection. So that unskilled operator immediately will get the information. This is the D symbol, means I have to go for the delay. That means I have to stop the machine. Inspection, if the square symbol is represented in front of that unskilled operator, immediately that unskilled operator will get the information. Now I have to go for the inspection, I have to go for the checking. So like that, these are the 5 symbols which are used in the method study, and through this particular symbol, all the process, whatever your total raw material is converted into the finished goods, all the activities can be represented in the symbolic manner. Therefore, this is your third experiment based on the chapter number 2, which is added in your syllabus. So here, if I have to represent that particular all the information, so this is a worksheet. So this is the worksheet. This is the sample format. So whenever I am representing all the information in the symbolic manner, so first of all we have to prepare this particular sheet, or this particular sheet is given to the operator, and according to that particular sheet, the operator will start their job or start their task. So the heading is given to this particular sheet as a worksheet. Okay. Then presented method, proposed method. So whatever the methods, whatever the task you have given, so whether it is presented method or the proposed method, as per the requirement of that particular method, you have to get tick mark. If it is presented method, you have to give the tick mark. If it is proposed method, here you have to give the tick mark. Then activity charted. So here you have to give the name of that particular activity, which task we are performing. Whether you are performing, whether you are preparing the nut, whether you are preparing the bolt, or whether you are preparing the shaft, or whether you are preparing the spring, like that, the name of that particular job, it is here you have to give it as a activity charted. Then second, department. In which department we are performing this particular activity? Maybe you are performing the production department, you are performing in the design department, you are performing in the R&D department, inspection department. So wherever we are performing that particular task, the name of that department you have to write here. Operator. So here you have to write down the name of operator. So the one operator is operating the lathe machine. So the worker who is operating that particular lathe machine, the name of the operator is written over here. So this is the name of operator. Then date, on which date you are performing that particular task, their date charted by chart number, charted by here again the name of the operator, or sometimes here you can write down the name of your supervisor who has assigned that particular task. Then chart number. So maybe 10 lathe machines are there and you are working on the 9th lathe machine. So this is the chart number as a 9 because you are working on the lathe machine number 9. So like that, whatever the necessary information is there, that necessary information you have to write down at the top side. Then here the number of columns are there. That is serial number is there, distance is there, time is there, and the chart symbol is there, and the process of description. So serial number you can write, for example, 10 operations you have to perform. So in the serial number I can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that I will write the serial number. Distance. How much amount of distance is traveled by that particular operator whenever he is operating on the machine. Sometimes one operator is handling the 2 machines. Sometimes single machine is handled by the single operator. So in that case, if there is no any distance traveled by the operator, so you can mention that particular distance 0, 0, 0. If the operator is traveling the distance from one machine to the second, that distance traveled by the operator you have to represent in the second column. Then time. This is very important. In case of a chart, this time and the chart symbol, it is very important. Time. Now, first of all, you have started with the turning operation. Here I can write turning operation means I have to represent the symbol O. How much amount of time is required for the turning operation? 3 minutes. So you can add in time column, I will write 3 minutes. Symbol for the operation, I will represent O, and in front of that, process description. Which operation I am performing? Turning. Then second serial number, distance is 0 because he is performing on the same lathe machine. In the second row, time required, I will write 2 minutes. Symbol, one more operation I am performing, capital O, and description, facing operation. After turning operation, I am performing facing. Then third number, serial number, again distance is 0 because same lathe machine I am using. I will write down the 5 minutes. 5 minutes in front of the 5 minutes in the third row, again I will represent the operation capital O. In front of that, I will write down the threading operation. So whatever the number of operations we are performing to that particular each and every operation, you have to draw their symbol, you have to write down the time required for that particular operation and their description in the last column. After performing the 3 operations, if I am taking the delay to change the tool, then in the fourth row, serial number 4, distance 0, time 2 minutes, delay capital D. For which purpose I am taking the delay? I will write, that is, I have to change the tool. After that, fifth number, if I have to go for the inspection, serial number 5, distance 0, time 5 minutes. For the inspection, symbol for the inspection, you know, square is there. Which inspection we are doing? I am checking the diameter of that particular job. So whatever the sequence of operation is decided, according to that particular sequence of operations, we have to write down the time required to the each and every operation, their symbol, and which operation you are performing. Whether you are performing operation, whether delay is there, whether transportation is there, whether inspection is there. So that operation is represented in the last column as a process description. And once I am performing all the operations, at the end, I have to give the summary. So whatever the summary is there, how many operations I have performed? For example, 10 operations. So represented method, proposed method. So 10 operations I have performed. How many transportation are there? Only 1 transportation is there. How many times I have done inspection? For example, 2 times. So I will write down the 2. How many times I have went for the store department or the storage? Only 1. How much amount of time is required for the delay, or how much time the delay is taking place? 3 times. I will write down the 3 times. And here I will write down the distance traveled. If the operator has traveled, for example, some amount of distance, the total distance traveled by the operator I can write in the last row. And like that, we have to prepare this particular worksheet, and through this particular worksheet, you can get the detailed information of that particular task. That is, how much amount of time is required to convert your raw material into the finished goods. And through this particular chart also, you will get the sequence of operation at first which operations I have to perform, second type of operation, third type of operation, then at fourth time you have to take the delay, at the fifth time again I have to go for the inspection. That means detailed sequence of operation you will get through this particular chart along with time required to perform that particular operation. So this is the one sample chart which is mostly used in the industry under the concept of the method study. So like that you have to prepare this particular chart, and at the end you have to write down the summary. So summary should be represented in the form of this particular chart: number of operations, number of transportation, number of inspections, store, delay, and if the distance is traveled, the total distance traveled by the operator also I can write over here. So this is the basic explanation related to the method study. Now we'll take one sample problem. We'll take one sample problem, then you can easily understand. Okay? We'll take sample problem. So task, for example. Okay, so one task is given to me, that is to perform drilling operations on job. So I have to perform the drilling operation on one job. So two drilling operations I have to perform. One phi is equal to 20 mm drill I have to take, and another phi is equal to 10 mm. So this task I have to perform, and one job is given to me. For example, this is my job, and on this particular job I have to perform the drilling operation of 20 mm and one more drill of a 10 mm. So this is 20 mm and the second drill is 10 mm. Okay, so when a rectangular section is there, and on that particular rectangular sections I have to perform the drilling operations. So two drill I have to perform, that is one diameter is the 20 mm and another is the 10 mm. So this is my task name, that is to perform the drilling operations on the job. And for this particular task, if I have to draw the process chart, so simply here I will write the time symbol and here description. Okay, so the third three columns: serial number, the distance travel, it is not required because we are performing the same operation by using the drilling machine only. So I will not take the serial number, I will not take the distance traveled by that particular operator. So first, whenever we are performing the drilling operation, let us assume that one job is given to you and you have to perform the drilling operation. So what is the first requirement? You have to take that particular job and you have to hold that particular job on that particular drilling machine. So first, I am performing the one operation. Number one, how much amount of time is required to holding the job? For example, 2 minutes. Which task I am performing? Descriptive. Hold the job on machine. Holding, because without holding the job it is not possible to perform the drilling operation. How much amount of time is required? 2 minutes are required. Okay, then after that another second operation I am performing, again I am taking the 2 minutes. First is represented by holding the job. Then what is my second task? I have to attach the drilling tool in the drilling machine. So what is the description? Attach drill tool of 20 mm. I am performing the first drilling operation of 20 mm. Attach the drill tool of 20 mm in drill machine. Okay. Second operation is performed. First operation, holding the job. Second, I have to attach the drill tool. Then third, three minutes. I will give the sample. 3 minutes. Perform drilling of 20 mm. That means 20 mm drill. I have used that particular drilling machine. I have drilled that particular 20 mm drill in that particular job. Then after that, what I will check? I will go for the inspection. Whether 20 mm drill is there or not. I have to check no. Whether 20 mm drill is there or not. So inspection symbol I have used single time. Therefore, at the center, I will write down the one. So here, inspection of 20 mm drill. How much amount of time is required? Only 1 minute is required. To checking the drill dimension by using the vernier, only 1 minute is required. Once that task is over, second, fourth times, 2 minutes. Now I have to perform the 10 mm drill. Already 20 mm drill is attached to the drill machine. Okay. After performing the 20 mm drill, I have checked whether 20 mm drilling is happen or not. After that, if I have to perform the 10 mm drilling operation, it is not possible to perform the 10 mm drilling operation by using the 20 mm tool. So what is my task? I have to remove the 20 mm drill and I have to attach the 10 mm drill tool. So here I am performing one operation, that is remove 20 mm drill tool and attach 10 mm drill tool. How much amount of time is required? I will increase the time. 3 minutes I will take, because remove the tool and attaching one more tool. That is 3 minutes are required. Okay. Then next. Now the 10 mm drill is attached. So here, fifth, 2 minutes, for which perform 10 mm drill in job. Now the drilling operation is performed. Once again, after 10 mm drill, again I will go for the inspection whether 10 mm drill is performed or not. So inspection symbol I am using second time, therefore second. How much amount of time is required to checking that particular diameter? Again, checking 10 mm diameter. Okay. Now the inspection is over. Then next, sixth, 1 minute. For which purpose? Remove the job from drill machine. Whatever the job we have holded on that particular machine, that job we have to remove. So remove the job from drill machine. And last, I will increase one more symbol. It will be move to the store department. Once your job is removed, we have to keep that particular job at the store department. So job is moved to store department. That means whatever the drilling operations I have to perform, this is your day-to-day application. You have observed that particular things. If I have to perform the two drill operations in the drilling machine, first time at a one time we have to attach only one tool. So for my first task is I have to hold the job. I have to attach the 20 mm drill. I have to perform the 20 mm drill operation. After 20 mm, I have to check by using the vernier whether 20 mm drill is happen or not. Therefore, inspection is there. Then fourth number, remove the 20 mm drill tool and I have to attach 10 drill tool. That means here the operator is working because removing the tool and attaching the new tool. Here operator is required. Then again I am performing the 10 drilling on that particular job. Again I am checking by using the vernier caliper whether 10 drill is there or not. And at the end, removing the job from that particular job machine. Maybe the different types of jaws is there, chuck is there. From that particular chuck or from that particular attachment, I have to remove that particular job and I have to move that particular component in the store department. So like that, from start to the end, whatever the activities I have performed, all that particular activities can be represented in the symbolic manner. So here the three symbols I have used. One is the capital O, or it is represented by circle. One more symbol we have used as a rectangle or the square, which is called as inspection. And at the end, I have used one inverted triangle, which is called as a storage. So here, how many symbols I have used? For example, 1, 2, 3. So operation. Then inspection. And last, storage. At the end, I have to represent the summary also. Therefore, how many times operation symbol is used? Let us see. How many times operation symbol is used? So 1, 2, 3, 4, 5, 6. So 6 operations I have performed. Total 6 operations I have performed on that particular job while drilling operation. How many times inspection is taking place? Number 1, number 2. And how many times the store is there? Only single time. For operation, how much amount of time is required? Let us see. At the left side of that particular symbol, the time is represented, and there at the right side, the description of that particular symbol or whatever the task I am performing, that task I have represented. So represent, measure the time for the operation. So 2 minutes, 2 minutes, and 2 minutes. So 3 plus 2, 5, 5 plus 2, 7, 7 plus 3, 10, 10 plus 2, 12, and 12 plus 1, 13 minutes operation. Inspection, here 1 minute, here 1 minute, so 2 minutes. And inspection storage 2 minutes. And if I will measure the total time, 13 plus 2, 15, 15 plus 2, 17 minutes. Means whatever the true drilling operations I have performed on this particular job, to perform this particular task, I required total 17 minutes to perform the 2 drilling operations. So like that, we have to represent the operation process chart. So through this particular chart, you will get the information about each and every operation, how many operations I have performed, 6 time operation, 2 times inspection, and 1 time storage there. At the left side, I have represented the time, so you will get the time required for the each and every task. At the right side, you will get the detailed information, what task I am performing. Also, you will get the sequence of operations. At first, what I have to do. At the second, what I have to do. At the third, what I have to do. So through this particular chart, you will get the sequence of operation. And at the end, so whatever the summary I have represented, in that particular summary, I have represented number of operations performed, 6, number of inspection, 2, number of store, 1, their time is also represented in front of that. And at the end, if I have made the addition, I got the answer 17 minutes. That means whatever the 2 drilling operations I have performed on that particular job, to perform that particular drilling operation from start to end, the 17 minutes are required. So like that, you have to draw the operation process chart. So this is the one sample problem just I have explained for your understanding purpose. Like this, so many operations we are performing. If you take the example of our lathe machine, in our day-to-day applications, we have performed the job on the lathe machine at your 3rd year. So one simple rod, circular rod is given to you, and you are converting that particular rod in the finished goods. Initially, you are performing piecing operation to reduce the diameter. Then you are performing the initially you are performing the piecing operation to reduce the length. Then you are performing the turning operation to reduce the diameter. Then you are performing some chamfering operation, maybe some taper operation. After that, you are performing threading operation. So like that, number of operations you are performing, that each and every operation can be recorded by using this particular chart, and that charts are called as a operation process charts. So there are different types of the charts are there. Basically, there are 5 types of the charts. The first one is a operation process chart. Second one is called as a flow process chart. Then third is called as a two-handed process chart. Fourth one is called as a multiple activity chart. And fifth one is called as a travel chart. So what is the meaning of first operation process chart means? Whatever the operations we are performing, all the operations can be represented in the symbolic manner along with time. That chart is called as a operation process chart. Second, flow process chart. Flow process chart is furtherly divided into the three types: man type, material type, and the equipment type. What is meant by the man type? So whatever the movement of the man or the operator is taking place from one machine to second, second to third, third to fourth, that movement can be represented by the man type of flow process chart. Then material. Whatever the raw material is moving from machine 1 to 2, 2 to 3, 3 to 4. So that movement of material, raw material, it is represented by the material type flow process chart. And third one is called as the equipment type or machine type. So whatever the sequence of machine we are using to convert your raw material into the finished goods, that sequence can be represented by the material or equipment type flow process chart. Then third one is called as the two-handed process chart. Some of the activities are there, that activities can be performed by your left hand and the right hand. So whatever the task is performed by the left hand, separate chart I am drawing. Whatever the task I am performing by the right hand, separate chart I am drawing. Therefore, two hands I am utilizing to complete that particular task, and that movement of the left hand and right hands are represented by one chart. That chart is called as a two-handed process chart. Okay. Then fourth, multiple activity chart. Sometimes operator he is performing the multiple activity. Sometimes handling the machine number 1, machine number 2, machine number 3. Sometimes machine is working, operator is in idle condition. Sometimes operator is working, machine is in idle condition. So like that, number of multiple activities are represented by the multiple activity chart. And last one is called as a travel chart. Name itself suggests. Travel means the directions of the material, whether it is moving in the right side, left side, front side, back side, top side, or the bottom side. That movement can be represented by the travel chart. So this travel chart is applicable for the material as well as worker also. So these are the different types of the chart. In detail we have discussed in the chapter number 2. But here I have represented one chart in front of you for the drilling operation. So whatever the task we are performing from start to the end, that each and every activity I am represented in the symbolic manner. So here the symbol is represented at the center, at the left side, the time is represented at the right side, the detailed description I have written, and at the end I have done this summary, and from that particular summary it has been observed that both the drilling operations I can perform in the 17 minutes. So this is your second experiment. So that's why here I have given one example, and through that particular example I have explained this particular operation process chart for the drilling operation. So this is your second experiment. And here this is the worksheet already I have explained in advance. So whatever the figure we have drawn here, whatever the points we have discussed here, this particular point, whatever this chart I have drawn for the drilling operation, same chart I can represent in this particular worksheet manner. So here again same format is there: name of activity, department, operator name, date, chart number. Here I have not represented serial number and the distance because I am performing the drilling operation on single drilling machine. So the operator is not moving from machine to machine. Therefore, the serial number and distance I have eliminated. I have taken the time, chart symbol, and I have taken the process description. Also, I have represented the summary at the end, and through that particular summary, it has been observed that within 17 minutes, I can perform both the drilling operations of the 20 mm and the 10 mm. So here, the two words they have mentioned, presented method and the proposed method. Proposed means the plan. Drilling operation I can perform in the 5 minutes. This is the plan. But in actual, that drilling operation can be performed in the 4 minutes only. So here, in the presented method, you will get the 4 minutes. In the proposed method, you will get the 5 minutes. What is the difference? 1 minute. So proposed means this is the plan, rough value. For the operation, 5 minutes are required. For the transportation, 10 minutes are required. Inspection, again 5 minutes are required. This is a one analysis. This is the rough value. But whatever the actual value you will get while performing that particular task, that actual value you have to represent in the presented method, and whatever the value planned, whatever the amount of time is planned, that time or that particular number of operation can be represented in the proposed method, and their difference we can represent at the last. But many times this presented method and the proposed method, like that summary is not required. Only you have to write down the summary like that, whatever I have written here. Operation 6 times, inspection 2 times, storage 1 times. Then I have made the addition, and at the end I have written the 17 minutes to complete that particular task. So this is about the method study. This is your experiment number 3 or the assignment number 2, in which you have to generate one operation process chart for any of the tasks. So here I have given the example of drilling operation, and for that drilling operation, how the task will be performed, that I have represented through this particular operation process chart. So this is your experiment number 3. Then the second experiment you are having, just we will take the 5 minutes explanation and then we will stop. So whatever the chapter is going on in our class, that is work measurement. In that particular work measurement, total 3 techniques we are using for the work measurement. Out of that, first one is called as a time study, in which I am using the time study equipment to measure the time. Time study equipment in the sense I am using the stopwatch, sometimes I am using the time study sheet, sometimes I am using the time study board. So means different time study equipments I am using under the time study concept. In addition to that, in the morning, we are having one lecture. In that we have discussed the remaining 2 methods, that is work sampling and the PMTS. So work sampling, in case of a work sampling, no any equipments are required. Only supervisor is taking the number of observations over a period of time. In the morning session, afternoon session, evening session, at the night, again that supervisor is taking the number of observations, and through this particular observation he can go for the work measurement. And the last method is called as a PMTS, predetermined motion time study. In that, name itself suggests that before starting your task, in advance we are deciding the time required to complete that particular task, or after the movement of the operator is taking place from one location to the another location, that movement is also planned. For example, I have to move from machine number 1 to 2. How much time is required? 2 minutes. So this is a rough value, 2 minutes. But sometimes I can move from machine 1 to 2 within 1 minute. But rough value we have decided as a 2 minutes. That means in advance, before starting that particular activity, before starting that particular movement, I have decided one rough value. Therefore, that method is called as a predetermined motion time study, which is also called as a PTS. But based on the work sampling and the PMTS, we are not having the experiment. We are having the experiment based on the first only, which is called as a time study. So experiment number 3, which is related to the method study, and experiment number 4, both are correlated with each other. In the experiment number 2, whatever we have discussed just now related to the drilling operation, from that particular method, you will get the sequence of operation. From that particular method, you will get the sequence of operation. But whenever I am measuring the time, so you can see here, at the left side, up to the time I have represented 2 minutes, 2 minutes, 3 minutes, 1 minute, 3 minutes, again 2 minutes, 1 minute, 1 minute. So that time can be calculated by using the stopwatch or by using the time measuring equipment. Means here I have implemented the concept of method study to set the sequence of operation, as well as I have implemented the concept of time study to measure the time required for each and every operation. This chart cannot be prepared by using the single concept only. So here the concept of method study and the concept of time study, it is also implemented. But in advance, I have represented the time. Means here I have used a stopwatch. If I am holding the job on that particular machine, if my operation starts, I will start the stopwatch. Once the job is properly holded, I will stop the stopwatch. How much time is required? 2 minutes are required. Means I have implemented the concept of time study. So the method study concept is applicable to set the sequence of operation. But along with that, we have to implement the concept of time study in order to measure the time required to perform that particular task. And that experiment number 4 is totally based on the time measurement. So whatever the operations we are performing, maybe drilling, milling, facing, turning. So for each and every operation, I am measuring the time. If I am performing the inspection operation, means I am checking the dimensions by using the vernier caliper. How much amount of time is required to checking the dimensions? That also we have to measure. If I am changing the tool, how much amount of time is required to change that particular tool? If I am changing the coolant, if I am changing the oil, if I am traveling from one machine to the second machine, each and every activity, it is represented by using this particular time study concept. So, and the same things are explained here. So detailed procedure also represented here. This is the data analysis, how to go for the data analysis. Then at the end, how to generate that particular report. So whatever the worksheet is there, in the previous experiment, we have discussed about the one sheet. In that, serial number is there, distance traveled is there, then time required is there, then symbol is there, and then at the end, description is there. But in case of a time study sheet, there are so many parameters are there. The top portion is same. You can see date is there, operation, on which machine you are performing, you have to write down the machine, name of the worker, analyst means supervisor, name of the supervisor, start time, finish time, at which time you have started your machine or you have started your task, at which time you have finished your job, that start time and the end time you have to represent. Then here part number, so whatever the part number is given on that particular drawing, that you have to represent, tooling, work number, elapsed time, that all the information, basic information you have to fill at the top side, and whatever the bottom portion, at the bottom side, whatever the number of columns are there. Once again, serial number is there, second column, element description. So whatever the task I am performing, that description you have to write here. Third column, speed and feed. So for each and every machine, there are having some input parameters or the output parameters. So at which input, what is your speed, what is your depth of cut, what is your feed, that information you have to write over here. And here in front of that, so number of readings are there from 1 to 10. So here they have represented PABS, PR, TN. So these are the parameters which we have to measure, or these are the parameters which we have to measure the time. So in front of that particular task, you have to measure the time, and at the end you have to take the average. So like that, whatever the number of operations I am performing, to the each and every operations I have to measure the time. But in case of a method study concept, I am measuring the time directly, 2 minutes, 3 minutes, 4 minutes. But here, for this particular time study sheet, you will get the detailed information. What is the feed rate? What is the speed rate? What is the depth of cut? For which parameters we have taken the readings? How many readings I have taken? So here I have taken 1, 2, 3, 4, up to 10. So 10 readings I have taken. 3 different readings I have taken. At the end, I have taken the average. So whatever the 2 minutes I have calculated, that 2 minutes you will get from this particular time study sheet. So like that, whatever the task we are performing, that task we have to represent in the element description, and you have to represent their feed, speed, depth of cut, and in front of that you have to measure their time, and at the end you have to take the average, and at the end, whatever the average column is there, at the end, here at the end I can write down the total time required to finish that particular task. Therefore here you can see here at the end I have written 17 minutes, 13 minutes plus 2 minutes plus 2 minutes, you will get the answer 17 minutes. That 17 minutes you will get in the last row. That is normal time time required to perform the operations only. Here, the effect of allowance is not considered. This total 17 minutes represents the time required to perform the job only. Here, I have not represented any type of allowance. While performing the drilling operation, the worker has not wait for drinking the water, he is not wait for washing the hands. Like that activities I have not represented, because this task is taking very short time. 17 minutes are very small. But if your task is very big, 2 hours, 3 hours, 4 hours, for such conditions, you have to give the different types of the allowances. But here, the allowance is not implemented. Therefore, at the end, until the time you will get, that time is called as a normal time. Or that normal time, it is also called as a basic time. Means time required to perform the operations only without considering any type of allowance. That time is called as a normal time or the basic time. So this is your experiment number 4. So experiment number 3 and experiment number 4 both are correlated with each other. From experiment number 3, that is by using the method study concept, you will get the sequence of operation, by which sequence you have to perform the task. But while performing that particular task, for each and every activity, how much amount of time is required, that time can be represented by using this particular time study concept or by using this particular time study sheet. If method study concept is available, at that time you have to implement the concept of time study also in order to measure the time. And the combination of method study and work measurement is called as a work study, because work study is one concept which is furtherly divided into the 2 types. First one is method study to eliminate the unnecessary operation, and second one is work measurement, which is used to measure the time required. And if I will manage both the method study and work measurement concept in the better way, then and then only you will get the maximum productivity, because your higher productivity is mostly depends upon the method study concept and the work measurement concept. Therefore, method study and the work measurement are mostly correlated with each other, and it is also called as a work study. Therefore, I have taken this particular 2 experiments simultaneously, method study and the science study. So this is about your experiment number 3 and the experiment number 4. Okay. So with this, today we will stop here. Remaining experiments we will take in the next lecture, because to take that particular remaining experiments, first of all we have to discuss some theoretical parts in your chapter number 5 and in your chapter number 6, and then you will better understood through this particular remaining experiment. Okay, so with this, today we will stop here. So once again I will give the overall remark, that is, today we have discussed about the experiment number 3 related to the method study, and the experiment number 4 related to the time study concept, which is called as a work measurement. By using the experiment number 3, we have decided the sequence of operation, and by using the experiment number 4, we have calculated the time required for each and every activity, and at the end, by making the addition, I will get the total normal time or total basic time to perform that particular task. And both the experiments we have understood by using this particular simple example of the drilling machine. That is, 2 drills we have to perform, and at the end I have represented the summary. Okay, so this is about the experiment number 3 and the experiment number 4. So with this, today we will stop here. The remaining part we will take in the next lecture.